We're looking at quadratic inequalities and absolute values. Let's refresh our memory. We recall that quadratic inequalities are solved like quadratic equations, except that we are interested in the region where the solution lies. We shall be using two approaches. The first is to sketch the quadratic graph, and this one will enable us to determine the region above or below the x-axis. That is at the point where it is greater than or equal to 0, or it is less than or equal to 0, either positive or negative. We will also be able to use the tabular or the chart format to determine where the solution lies in a given quadratic inequality. Let's say, for example, the equation x squared plus s minus 6 less than or equal to 0. And they are required to find the values of s for which this inequality is true. We are going to use the two methods or approaches to demonstrate how to find the solution set. The first thing we do is to factorize the expression, assuming it is equal to 0. Now, from quadratic equation, which we have studied, you have that this becomes s minus 2, s minus 3 equal to 0. So this is positive, because s times s is s squared, s times plus 3 is 3s, minus 2s will give you plus s, minus 2 times plus 3 will give you minus 6. Now, usually you talk about the roots. And what are the roots here? Our s is equal to 2 or minus 3. Now, using the first approach, we can sketch the quadratic function, the graph. This is your y-axis, this is your x-axis, this is your origin. And we recall that when the coefficient of s squared is positive, your graph will normally look like the U-shape format. We take the U-shape format. So this graph will take the U-shape format. So we now have something like this. Your interest is just to make a sketch that will help you to determine where the solution lies. The minus 3 will be on this side, and while the plus 2 positive is on this side. Now, if you carefully look at the symbol, the inequality symbol is saying less than or equal to. Anything that is less than 0 means it is negative. And looking at the graphical solution, it means below the x-axis. And this is the region that is below the x-axis. So below the x-axis, s lies between minus 3 and 2. Your solution is minus 3 less than or equal to s, s less than or equal to 2. Because this is the symbol that is used as far as the case is concerned. We have looked at the first situation. The second approach is the tabular form. Let's look at the tabular format. We have the boundary points. The boundary points are 2. Let's start with the list of them. Minus 3 and then 2. These roots are the boundary points. These are the boundary points. Then we roll across. Then we also rule. This is the chart now. So we now have, to this side of it, we have s minus 2. We also have s plus 3. These are the factors of the quadratic equation or inequality. Now, at the end, we will choose values that are less than minus 3, because we're looking at this side. What are the values less than minus 3? The next one is minus 4. Minus 4 minus 2 is minus 6. Take the sign, which is minus. Minus 4 plus 3 is still minus 1. So take the sign, which is minus. Then go to between minus 3 and 2. You can take even 0. A line between minus 3 and 2. You can take 1. You can take minus 2. So let's take 0. 0 minus 2 is minus 2. So it is still negative. 0 plus 3 is positive. It's plus 3. So the sign there is positive. You are interested in the sign in this operation. Then take values after 2. Values above 2. Greater than 2. You can take 3. 3 minus 2 is plus 1. So it's positive. While 3 plus 3 is 6. Is also what? Positive. Now you roll across. You now bring in the product of the two factors. So s minus 2 times s plus 3, the product of these two factors. S minus 2 times s plus 3. You are looking at the signs now. Minus times minus is plus. Minus times plus is minus. Plus times plus is plus. Now, referring to the question, they are interested in where the left hand side is less than or equal to 0. Less than 0 means when it is negative. And if you look at your chart, the chart is negative between minus 3 and 2. So you therefore say that, therefore, your answer is minus 3 less than or equal to s, s less than or equal to 2. The region where it is negative. And that's exactly what they are asking for. Assuming the question, assuming s squared plus s minus 6 is greater than or equal to 0. From the graph which you sketched earlier, this was the graph. And then this region was the minus 3. And this point, sorry, and then this one is 2. But this time around, you are interested in the region where the graph is above the s-axis because it's greater than. This is where it's above. This is where it's above. So it therefore means that our solution in this case, our s is less than or equal to minus 3, or our s is greater than or equal to 2. Then from the chart, if you look at the chart, from the tabular chart or the tabular form, the area that is positive is s less than or equal to minus 3, or s greater than or equal to 2, which agrees with the first solution. So any of this method can be used to find the region where the solution lies in a quadratic inequality. Let's take an example. Number 1, find the range of values of s which satisfies the inequality 12s squared minus s minus 1 less than 0. Let's look at the solution. We have here 12s squared minus s minus 1, take it to be equal to 0. Now, what do? Take note that the coefficient of s squared here is positive. So what do? We factorize this. To factorize this, you have the 12s squared minus 4s plus 3s minus 1 equal to 0. You remember 12 times minus 1 is minus 12, and then of course minus 4 times 3 is minus 12, and minus 4 plus 3 is minus 1, which gives you the coefficient of the middle term. So you cannot pair them, and what is common is 4s, and here 3s, and here is 1, plus 3s and minus 1, 1 is common, so 3s and minus 1, everything equal to 0. What next? It means that 3s minus 1 is equal to 0, or 4s plus 1 is equal to 0. So what next? Our s here will be equal to 1 over 3 or minus 1 over 4. As I said earlier, you cannot decide to use either the chart or the sketch. So let me use the sketch. This is your s axis, your y axis. Now we have 1 over 3 and minus 1 over 4, so it's crossing over. We have something like that. This point is your minus 1 all over 4. This point is your 1 all over 3. Your interest is to look for the region where it is less than 0. Again, this is the region where it is less than 0. In this case, you can now write your solution: minus 1 over 4 less than n and less than 1 all over 3. You will have solved that problem without any difficulty. Absolute value. If p is any non-zero real number, the absolute value of p, denoted absolute value of p or modulus p, is defined by the modulus of p equal to p if p is greater than 0, or minus p if p is less than 0. Second point, if the modulus of s minus p is less than or equal to q, then it means minus q is less than or equal to s minus p less than or equal to q, or p minus q is less than or equal to s, and this is less than or equal to p plus q. All we have done here is, if you take minus p to this side, it becomes positive, so p minus q, and if you take it to this side, it becomes also positive, p plus q. Thirdly, if the absolute value of s minus p is greater than or equal to q, then minus q will be greater than or equal to s minus p, and this is greater than or equal to p. Or, just like the previous one, if you bring your minus p down here, it becomes p minus q greater than or equal to s, and this is greater than or equal to, if you take minus p this way, p plus q. So these rules we are going to use in solving problems involving absolute value. Example 1. Let's take it as example 1. Number 1. Solve the inequality modulus of 2s minus 5 less than 1. Our solution: record the format of removing the modulus: minus 1 less than 2s minus 5 and less than 1. What now happens? You take your minus 5 to your left hand side, becomes plus 5, minus 1, remaining 2s here. Take the same minus 5 to your right hand side, less than 5, and then plus 1. This will give you 4 less than 2s less than 6. Since 2 can divide all through, we have 2 less than s and then less than 3. So this is the final result as far as this problem is concerned. Exercise number 1. Solve the inequality y squared minus 3y greater than 18. The options A, B, C, and D. The second one, solve the inequality 2 minus s greater than s squared, and you have options A, B, C, D. The third one is solve the inequality. Modulus of 2x minus 5 is greater than 1. And we have options A, B, C, and D. So we have the answers. For number 1, the correct option is B. For number 2, the correct option is D. For number 3, the correct option is A.